Greetings, my wonderful little sixth graders. How are all my pork chops doing today? I hope you're doing well. I hope you're having a good day, and I hope you're ready to do some learning. So today we're going to talk about LCM, which stands for least common multiple. All right, and our lesson objective, which, remember, our objective is what do we want to accomplish by the time we're done working with LCM. So our objective is we will find LCM of two whole numbers. And then our deeper thinking question, the question that makes us think a little deeper, is what is a real world situation where you might need to find the LCM of two numbers? Because remember, everything that I teach you in math, a lot of people will say, I don't know why we have to take math. We never use it in the real world. But everything I teach you does have some form of a real life application. We can use it in real life. So it's so helpful if instead of saying, oh, I'm never going to use this, it's helpful if instead we say, well, what is a real world situation where I might use this? If you start thinking that way, you'll start seeing math everywhere. Okay? So let's get started. We're going to start with our notes. All right, at the top of our note page. Remember, brand new note page, and as always, if I am writing, then you are writing. Remember, I will be checking those math notebooks. Least, common, multiple. That's what we're learning about today. Also known as LCM. And we'll probably say LCM more often than not, but it's important that you obviously know what LCM stands for. Okay, so as always, I like to get a little vocabulary out there so that you understand what we're talking about. First of all, let's talk about what is a common multiple. So a common multiple multiples are multiples that are shared by two or more numbers. Okay? And then in addition to that, I want to talk about least common multiple. So least common multiple and I like to underline our vocabulary words so that we can find them easily. Least common multiple is the least of the common multiples of two or more numbers. Okay. So if you were sitting in my class, the next thing that I would say is I would pose a question and I would say, okay, who can tell me what a multiple is? And you're not sitting in my class, so I can't ask it in the same way. So I am going to ask you, what is a multiple? Think about that for a second. What is a multiple? I want you to think about it for a second. Okay? Now, hopefully you're remembering that a multiple is when you multiply a number and you make it bigger. So for instance, if I want to know the multiples of 2, well, if I multiply 2 times 2, it's answer is 4. So 4 is a multiple of 2, okay? So now what I would ask you to do is think about what's the difference between a multiple and a factor. They're very related to each other, but there's a difference between a factor and a multiple. So a couple of ways you can think about it. Well, first of all, factors are smaller than the starting number because factors go into, all right? We can divide factors into our starting number, all right? So remember that factors usually tend to be smaller. They go smaller than our starting number. Multiples are when we're multiplying our starting number times other numbers. So our number is growing. Okay, so our multiples tend to get bigger. Okay. All right, so let's dig in and start by finding some LCM. Okay, so first of all, just like in GCF, there's multiple ways of finding LCM. So first, we are going to find the LCM by listing multiples of 4 and 6. Okay, so that's what we're going to do first. Okay, so, and remember, if I'm going faster than you're writing, it's okay. You can pause the video, catch up, and then restart it. That's one of the nice things about watching the video lessons, okay? Okay, so we're going to list multiples. You guys know how to list multiples. That's essentially the same thing as skip counting, which you did in 1st and 2nd grade. So let's list the multiples of 4. Okay. Obviously, 4 is a multiple of 4 because 4 times 1 is 4. So we start with 4. 4 times 2 is 8. And I can continue. 12, 16, 20, 24, 28, 32. I'm going to stop there. So let's see, I did 1, 2, 3, 4, 5, 6, 7, 8. And at the very least, for most of our problems, the least number of multiples you should be looking for is at least 6. If you get to 6, you can stop and see if you've found your LCM yet. Okay, so our next number is 6. And again, I'm going to do the same thing to list my multiples. 1 times 6 is 6. 2 times 6 is 12. 18. 24, 30, 36, 42, 48. Okay, now all I have to do is look for my common multiples, right? Remember, common multiples are multiples that both numbers share. So my common multiples. Well, 6 does not share that multiple. 6, nope. 8, nope. 12, look at that. They both share 12. 16, nope. 18, nope. 20, no. 24, yes. 30, nope. 28, sorry, skipped. Nope. 32, nope. 36, nope. 42, 48, we didn't go that high. Okay? All right, so now I found my multiples, but what's my least common? Remember, least is not the greatest number, it's the lowest number. So it's the lowest of the multiples. What's my least common multiple? That would be 12. Okay, so now I'm going to give you 3 problems to try, and you're going to pause the video, and you're going to do the same thing. copy these problems down, pause the video, and list the multiples for these numbers and find the LCM, okay? Then when you come back and you unpause the video, we're going to be solving them. Okay, so I'm solving these problems. I've got 3 and 8. Okay, well, so for 3, I've got 3, 6, 9, 12, 15, 18. 1, 2, 3, 4, 5, 6. Okay, so we'll stop there. Okay, and then for 8, I've got 8, 24. Oops, so sorry. Sometimes my brain just works faster than my fingers can work. 8, 16, 24, 32, 40. Okay, well, let's take a look at our list. Do I have any common multiples? 3, 6, 9, 12, 15, 18. None of them work for my least common multiple. So guess what that means? I started with 6 multiples, but I'm going to have to keep going, aren't I? Okay, so let's go with 3 times 7 is 21. 3 times 8 is 24. Oh, look, I could stop because look what I just found. I finally found my least common multiple. Okay, so my LCM for 3 and 8 is 24. Okay? All right, let's do number 2. Number 2, we have 9, 18, 27, 36, 45, and 1, 2, 3, 4, 5, 6, 54. For 12, we have 12, 24, 36, 48, 60, and 72. Again, I'm looking for my multiples. 9, no. 12, no. 18, no. 24, no. 27, no. 36. So my LCM is 36. Okay, last one for 6 and 10. All right, for 6, we've got 6, 12, 18, 24, 30, 36. 1, 2, 3, 4, 5, 6. I can stop, see if this will work. Okay, for 10, I've got 10, 20, 30, 40, 50, 60. Okay, well, let's see. 6, not common. 10, not common. 12, not common. 18, not common. 20, not common. 24, not common. 30, common. There's our least common multiple. So our LCM equals 30. Is this not so easy? Okay, now we've looked at how do we find the LCM using listing of multiples. Now let's take a look at how do we find the LCM using prime factorization. So, find the LCM of 16 and 20 using prime factorization. Okay, this is like our 5th or 6th day doing prime factorization. So hopefully you remember the first thing you should do is start a number tree for the first number. So 16. Let's do our factor tree. And like I have said to you before, you can use any two numbers that are actual factors for 16. I like to start with the lowest prime number, so that's what I'm going to do, okay? So the lowest prime number that goes into 16 as a factor is 2. So I've got 2 and 8, and because I started with 2, it's prime and I can kill that branch. I don't have to do anything. I circle the 2 and I'm done on that branch. Now I'm on this branch. Now I have 8. Again, 2 goes into 8, so 2 is my lowest prime number, and it goes into 8 4 times. And 4 is not prime, so I'm going to keep working, and 2 goes into 4, and it goes in 2 times. So now I have all prime numbers. Okay, so the prime factorization for 16 is 2 times 2 times 2 times 2. Oops, sorry, I don't know why I put that extra times there. Extra multiplication sign. Okay. Or another way to write this is 2 to the 4th power, because I'm using the 2 4 times. 1, 2, 3, 4. So 2 is my base, 4 is my exponent. Okay. Let's do 20. Okay, so 20. Again, I'm going to use 2 because 2 is a factor of 20 and it's prime. I like to use that prime number so I can kill that branch. 2 goes into 20 10 times. 10 is not prime, so I'm going to continue. And 2 is also a factor of 10. So 2 goes into 10 5 times. Oop, and 5 is a prime number, so I can circle that branch too. So I'm done with that one, okay? Okay, so now I'm going to list my factors, my prime factorization for 20. My prime factorization for 20 is 2 times 2 times 5. Okay, so right there you're probably saying, oh, okay, well, Miss Rodriguez, it seems like 2 is the least common multiple, but that doesn't make sense because 16 and 20 are bigger than 2. Okay, so remember, we weren't listing multiples here. This time we're using prime factorization. So we have to do another step in order to use prime factorization for LCM, okay? And so there's 2 steps, all right? The first thing that we're going to do is, first, we're going to find any unique, and this is or 2 to the 2nd times 5, okay? All right, the first thing we're going to do is find any unique factors. So when I say unique, I want to make sure that you understand that unique means different. It is not repeated in the other one, okay? So when I look at this one, I see I have 2's in both. So 2 is not unique, okay? But for 20, 5 is a prime factor for 20, right? So I'm going to go ahead and circle my 5. I'm going to use that 5, okay? Now, the second thing that you need to do is first you looked for unique numbers. Then what you're going to do is when you look at the common numbers, you're going to pick the higher value one, okay? So you see they both have factors, prime factors that are 2 and their powers, okay? So right here I have 2 squared and this is 2 to the 4th. So which one is the higher value one? Well, the higher value or the greater factor is 2 to the 4th, okay? Or I could have just circled 1, 2, 3, 4, and then the 2 there. The 5 there, okay? All right, so That means that the LCM is 2 to the 4th times 5. All right, so now what we have to do is do the math. We have to actually figure out what is the LCM, because this isn't enough. We want to know what's the multiple. What is the number? Okay, so 2 to the 4th is the same thing as saying 2 times 2 times 2 times 2, and then times 5. So 2 times 2, that's 4, times 2 is 8, times 2 is 16, and 16 times 5 is 80. So my LCM is 80. Okay, so I understand that this one seems a little bit more confusing for you at first, but in the long run it might actually be easier, especially when we get into working with more than 2 numbers. So eventually you're going to be doing this with more than 2 numbers, and then it will be a little easier to use prime factorization. But let's go ahead now, and you're going to practice. I'm going to give you some problems for you to practice with. We're going to go with number 1 is going to be 14 and 18. Remember, you're using prime factorization. And then for number 2, we're going to use 28 and 36. Okay, so again, you're going to pause the video, work these out using prime factorization, and then come back and you're going to watch me solve them, which I'm going to do now. Okay, so hopefully as you were solving these 2 problems, you were thinking about the fact, these numbers are a little higher, and if I were to list out the multiples, it's not quite as fun as going 2, 4, 6, 8, 10, or 4, 8, 12, 16, 20, 14, 28, 34. It gets a little bit more confusing when you're doing higher numbers and you're listing multiples. So this is one of the reasons why prime factorization is awesome. Prime factorization brings the number smaller instead of having to do all that multiplication, okay? So 14, we're going to do the prime factorization for 14 right here. 14, I know that 2 is a factor of 14. So I've got 2. And 2 multiplies times 7 to get 14. And guess what, guys? 7 is a prime number, so I circle it and I'm done. 14, done. All right, now I'm going to do 18. Okay, 18, I've got 2, goes into 18, right? And that'll give me 9 on this side. 2 is a prime number, but 9, not a prime number. Okay, so what prime number is the lowest prime number that goes into 9? Is it 2? Nope. 3. Yes. Okay, so 3 goes into 9 3 times. Now I've got 2 prime numbers. Okay, so now let me write my prime factorization for both. 14, sorry, I'm going to move up a little bit. 14, my prime factorization is 2 times 7. For 18, my prime factorization is 2 times 3 times 3. Okay, and remember, I can write this one as 2 times 3 squared. Okay, so now I'm going to look at all the factors here, okay? And just so that I know I'm not looking at both, I just go ahead and put one little line through this so I know I'm really just looking here, okay? All right, so I'm looking for, remember, unique numbers. One, unique. And then I'm looking for common but greater factors, okay? Okay, so if I'm looking for unique first, well, I see they both have a 2, don't they? Yep, they do. Hold on one second. I am so sorry. But I see that they do not both have a 7, and they do not both have a 3 squared. So I know I'm going to circle the 3 squared and the 7. Now, number 2, I'm looking for common but greater. Well, common, I have a 2 and a 2. Is either one of those greater than the other? No, because there are no exponents on either. So I'm just going to pick the 2, any 2. Either one. Just one though. Okay. So my LCM equals 2 times 7 times 3 squared. Or, okay, well, let's do that math. 2 times 7 is 14. And then 3 squared. 3 squared is the same thing as saying 2 times 2. That's 6. So 14 times 6. And if you need to use a little calculator for something like that, that's okay. Or you could do some side math to the side, but just for time, I'm going to do it really quick. So my LCM is 84. Okay? Remember, circle your answer or square it so that you know what it is. Okay? All right, next one. 28. Oh, gosh, I'm so glad I don't have to list multiples for 28. 2 and 14. 2 is prime. I'm going to work on the 14. 2 and 7. Whoop. 2 is prime. 7 is prime. Okay, 36. Okay, 2 and 18. That 2 is prime. 18. 2 and 9. That 2 is prime. And 9 is going to give me 3 and 3. Okay. Now let me list my factors. My prime factorization is 28 is 2 times 2 times 7, or 2 squared times 7. And 36 is 2 times 2 times 3 times 3. Or the better way to write that is 2 squared times 3 squared. Okay, so now remember, I'm not going to use these ones because I have them set up over here nice and neat. Okay, so I'm going to just do a little cross out so I remember, don't look at those. Okay, so first I'm looking for unique factors. Okay, so unique prime factors, I've got 7 is definitely unique, and then 3 squared is definitely unique, and then 2 squared is the same as 2 squared. So I have a common factor, and I'm going to take the greater one. Which one's greater? They're the same, so I just pick one. Okay. Okay, so my LCM is 2 squared times 3 squared times 7. Okay, so 2 squared is the same thing as saying 2 times 2, right? So that's 4. And 3 squared is the same thing as saying 3 times 3, so that's 9 times 7. Now it's kind of like order of operations, right? I just worked down. Okay, so 4 times 9 is 36 times 7, and 36 times 7 equals 252. So my LCM for 28 and 36 is 252. Now, when you look at that big number and you think back to, you would have had to count by 28s until you got up to 252 before you found a least common multiple. And you would have had to count 36, 72, and so on until you got all the way up to 252. That's why prime factorization is helpful in this situation, okay? Okay, so I have a word problem for us. Okay, so this word problem is our real world connection. So this is where we make a real world connection, okay? Let's say you and your friend have decided that you want to learn more about the civil rights movement. So you both decide to read a book. It's called A Step into History, the Civil Rights Movement. You read 30 pages a day, but your friend, she likes to read more. So she reads 40 pages a day. If you both started the book on the same day, how many pages would you both have to read until you were on the same page? So this is least common multiples again. And when you're solving a word problem like this, like let's say this came up on the EOD or something, you've got to use the tool that you want to use, okay? So what tool do you think would be most helpful? You're solving for LCM, you could definitely list multiples, or perhaps you might want to do prime factorization, okay? So we could do this either way. I think I'm going to do prime factorization. All right, so I'm going to do me is 30. And my friend is 40. All right. Smallest prime number that goes into 30. 2, 15 times. That's easy. 15. Smallest prime number that goes into 15. Does 2 go into 15? Nope. 15, I can use 3. And 3 is prime. And 3 goes into 15 5 times. And 5 is prime. Okay, let's do 40. So 2, prime number. 20, not prime number. 2, prime number. 10, not prime number. 2, prime number. And 5, prime number. Okay, so let's list our prime factorizations. So for 30, I have 2 times 3 times 5. And notice I don't have any repeat numbers here, so I won't have any exponents. Okay, and then for 40, I have 1, 2, 3 2s. So that's 2 to the 3rd power times 5. All right, so one more time, just like before, we are looking for unique factors first, the unique factors. So 2 is not unique. 3 is unique, okay? And 5 is not unique. Okay, then we're going to look for the common factors, the ones that are the same, but I'm going to use the bigger of the two. So I have a 2 and a 2 to the 3rd power, or 2 cubed. So which one's bigger? 2 cubed. And then here I have a 5 and a 5. Either one will work. Okay, so that means that my LCM is going to equal 2 to the 3rd times 3 times 5. All right, well, let's work that out because we're not done until we get to a number, okay? So 2 times 2 is 4, times 2 is 8, right? Yes. 8 times, I'm just trying to make sure I did that right. Yes, okay. 8 times 3 is, wait, I have a mistake on here somewhere. Hold on. Yeah, no, it's right. Okay, sorry. Okay, sorry, my bad. Okay, so 2 times 2 is 4 times 2 is 8. Now I have 8 times 3 times 5. So 8 times 3 is 18. And then 18, I am so sorry. I don't know what is wrong with me. 8 times 3 is 24, Lord. And then 24 times 5 equals 120. So my LCM is 120. My goodness. Sometimes even teachers have like brain issues. Okay. So we have worked through a bunch of problems doing this today. But you're not done. So here's your next part of your assignment. You're going to pause the video and you're going to, actually you don't even have to pause it, but this is what you're going to do. You have a math discussion board next, and this is your math to go. This is how you're going to show me that you understood what we were doing in our lesson, okay? So this is going to show me that you've met that lesson objective because you understand how to find the LCM of two numbers, okay? So look at what I did. I'm tricking you up and I give you 3 numbers to find because I figure if you can find 2, you can find 3, all right? So the first part of your discussion board is you're going to find the LCM for 4, 15, and 18, and you're going to use prime factorization to do it, okay? I want you to practice that prime factorization. The second part of your discussion board is you're going to create and describe a real-world situation where you might need to find LCM for 2 numbers, okay? And think about, I just used the reading a book situation, okay? So think about some other, don't use the same situation I used, but try and think of a different situation where you might need to figure out the LCM, okay? So you and your friend are doing this, or you're collecting this, and try and think of ways where you might need to use the LCM in real life, okay? And after you post, then you can reply to 2 of your classmates, okay? And remember, this is how you're going to show off. You're going to show how much you learned from this lesson. All right, guys, I will see you tomorrow.